today will be our last lecture, so we'll just wrap up. Wednesday there will be no lecture. So we'll wrap up the content, explain the exam, the type of questions that you will see, and also we'll take a look at a few practice exam questions. Right? And we'll post all of these materials online, so you will see the practice exam questions online. Okay. All right. So this diagram, right, illustrates all we have learned in this class. Right? So we'll quickly go through it as a quick review, and then after that we will explain which parts will be covered in the final exam. Okay. So this is the architecture of a computer and an operating system. So on the left side you have CPU, and CPU has a TLB. TLB is part of the memory management unit. And inside CPU, we learned that if you have a multi-core CPU, you can have each core can have their local cache, and there will be a cache coherence protocols. And CPU is interrupted. Right? Remember, CPU is a big cycle, infinite fetch and execution loop. And in every loop execution, it will check whether there is any interrupt. Right? So if there's any interrupt, it will invoke the corresponding interrupt handler. Clock, and here clock is one example of the interrupt. So periodically it will trigger timer interrupt, and so it will cause a context switch if there are multiple processes. Okay, and yeah, so that is inside the on the left hand side, inside that box. And on the right hand side, right, so we have the memory. Okay, so usually memory is split into user application memory and kernel memory. And we learned that this is a structure of the virtual address space of a program. In Xenu, we already see the example. Right? You have text, you have a data BSS section, you have heap, and you have stack. In Xenu, this is exactly what you see. Okay, and we also learned how this virtual address, right, how this virtual program address is stored in the physical memory, both in Xenu and also in the modern operating systems, which uses virtual memory. Right. How this is stored in Xenu is very simple. Right? So in Xenu, you have a shared text, BSS, and heap, but each process has its own stack. And that's how it happens in Xenu. But in modern OS, you have virtual memory. Right? Virtual memory, so every process's memory will be mapped to the corresponding pages or page frames in the physical memory through page table. Right. We learned how memory management unit uses a page table to map virtual memory to physical memory. Okay, and we also learned how TLB is used as a cache for the page table. Okay, so I'm just going through what we have learned. If you don't remember this, right, so make sure that you review the materials. Right. Virtual memory management, TLB, right, how TLB is used to cache this map, and these are all important concepts in operating systems. Okay. All right, and so that is memory, and then we learned disk management and file system. Right. So you have directories, iBlocks, data blocks. Right. This is how Xenu organizes its file system. on disk. Okay. But we also learned in a more modern modern operating systems how disk is organized using inodes into a file system. This is how Xeno does it. Very simple. Okay. All right. So this is TCY. Right? So this is just to show that there are other devices connected to this bus. Right? Not just you have disk, you have a memory, but you also have other devices. Okay. All right. So this part, right? This part is the memory, the data structures in memory. Right? So this is from kernel memory. We have these data structures. They are all from Xeno. Okay, they're all from Xeno. So yeah, on the left corner I have process table, and that's the very first kernel data structure that we learned. Okay, and we learned we also learned ready queue. Right? Processes are connected into this ready queue, and the OS will schedule the process that has highest priority on the ready queue to execute. Okay. We also learned semaphore, right? Read signal, right? How semaphore is implemented. Remember the semaphore queue, right? Semaphore table and semaphore queue. These are all we have learned all of this. And delta list. Right? Remember what is this delta list is for? Clock. Right? The clock management system. Right? So yeah, we learned about clock management. We learned this delta queue, and this delta queue is used to keep track of what is the next event that will happen for each process. Okay. For example, this is for process 1, maybe within 3 ticks. Right? After 3 ticks from now on, you need to wake up process 1. And then after that, after another, let's say this key is 4, right? After another 4 ticks, you need to wake up process 2, and so on. Right? This is the delta list. Okay? It is used for clock management. Okay, and we learn page table. Okay. So you have one page table per process, and but this is not specific to, not really for Xeno, right? This is for more general virtual memory management. Right? Every in like Linux kernel, you have one page table per process. Okay. Okay. And the subset. Right? So these page tables are cached at TLB, and this is for general virtual memory management. Okay. This is what's in Xeno, right? Xeno has this. Xeno has the low-level memory management that organizes memory blocks in free list, right? And you can create, allocate memory blocks from this free list. And you can create memory buffers. Okay. And this is the memory list. All right. And then device table. Right? We learned about the device and how even in Xeno, right? So everything can be viewed. A lot of things can be viewed as a device, right? File system, even each file has a pseudo device, right? So they have a device switch table, and each device they have a list of functions: open, close, read, write, get char, put char. And the reason that they have this uniform list of function APIs is because all of these devices are manipulated as if they are a byte stream. Each of them is viewed as a byte stream. Okay, So even later we come to we design file system and file, right? Each of them is also viewed as a device. Because file, right, for example, can also be viewed as a byte stream. Okay. All right. Yeah. We also learned device driver, upper half and lower half, right? Upper half and lower half. That is device driver is split into these two parts because part of the device driver is responsible for handling interrupts, right? Interrupt handlers, and part of the device driver is responsible for handling user requests. Right? Your user program will directly invoke, right? When you want to send a request to a device, your user program will need to be able to directly communicate with it. For example, if you want to write to your monitor, your console, okay, that's how your user program uses the device driver. And the other part of the device driver is responsible for handling the interrupts. Once some I/O operation finishes, the interrupt will be triggered. Sorry about that. And once the interrupt is triggered, the CPU will identify which interrupt handler is responsible for this interrupt, right? And it will find the corresponding device driver's code to handle this interrupt. Okay. So this is an interrupt vector. For clock interrupt, you have a clock handler, a TTY, you have a TTY interrupt handler, Ethernet interrupt handler, and disk interrupt handler. Okay. Right. So that's device drivers and interrupt handling. Okay. And then file system. Right. So inside memory, you have data structures that represent your file system. For the directory, you have directory entries. Right? It has each directory entry is a pair or mapping from the file name to the I block or inode. Right? In Linux, it's I block, the first I block of a file. In other OS like Linux, it's mapped to inode. So this is the inode, illustrates inode. You have a file, and in the file you have direct blocks. As these are pointers to the data blocks of this file, and then you have an indirect, right, and double indirect blocks. So these indirect blocks points to a block that stores pointers to data blocks. Double indirect and triple indirect, they store pointers to pointers of data blocks. So with more indirections, your inode can store more data. Okay. In Linux, it's much simpler. In Linux, you have a one directory block, and each directory entry points to the first I block of a file, and each I block is a list of pointers to the data block of this file. Right? And these I blocks are linked in the next list. Alright, so this is how Linux does it. So this inode and the page table is how other modern OS does it. This memory list, right? Inode, I block. This is how Linux does it. Okay. All right. So this is a quick overview of the core concepts we have learned in this entire class. Right. If there's anything that you do not remember clearly, right, you probably want to review it. Okay. And now let me quickly go over the final exam scope and questions. Yeah, so I will upload these contents after this lecture immediately. Right, final exam location and time. So hopefully everyone already knows it. Right? And scope, right? All the lecture contents, and there will be some before the midterm, but most of the content will be after the midterm. Okay. And the type of questions, you will have multi-choice questions, right? About interrupt file system and so on. And you have short answer questions, but it will be mainly focusing on the content after the midterm, right? Similarly, you will have long answer questions, but it will mainly focus on the content after the midterm. Okay? All right, so that is the type of questions and the exam scope. I will upload this onto the discussion. All right. Yeah, so our TA Lucas has some great review materials that he has used before. Yeah, let's go right to.
All right. Can y'all hear me? Okay. Laptop?
Yeah.
Okay. My bad, guys. Person using Linux, so. Okay. All right. So, you guys may or may not recognize me. I was here earlier. You may not, or you may know me from PSOs. I'm an undergraduate, same as you guys, and this will be my third time using these exam materials. I used them whenever I took the class, and I've used them previously to help students. I don't think we're gonna have time for a Kahoot today, but I'm gonna upload that afterwards, so you guys will be able to review it. But let's just get into it actually. Okay, here's the QR code. So I'm gonna have all this stuff available. I'm gonna post on the EdStem, and then we're gonna have some other stuff, but yeah, if you guys wanna just look into it, I'll give you a few seconds. All right. Everyone good? Okay. So here's just kind of an overview of it. It looks like a lot, and it's okay. We're gonna get through it quick. So, because our professor here has already covered some of it. So this is just some of the stuff he just went over, some of the metadata, that sort of thing. And here's the first thing. So vocab actually, it doesn't sound as important as it might be, but a lot of this stuff is like, it's deceptively important, especially because some of the questions I know on the midterm where they might have felt a little gotcha, might have, like if you didn't read very closely, a lot of this stuff, the same stuff comes up on the final. So for instance, something like, oh, I'm in waiting state, I can't use wake up. Like, just stuff like that, understanding what wake up applies to, what signal applies to, what send applies to. These are all things that'll be very much like, you should be thinking about them. Also, just so you guys know, I'm here like only for you. If you want to ask me any questions about what I think might be on the final, I've been thinking about it. I haven't had any part in developing the final, so I'm gonna keep going on here, but if anyone wants to interrupt me or ask a question, like, absolutely feel free to. Like, I'm more than happy to help on pretty much everything. But yeah, this is just some of the vocab just to start off. I would say these are also some of the most important data structures that you should know, as the professor just went over. Like understanding also which of these data structures are which, very important. But yeah, we'll move through as that's pretty much just vocab, not a lot to say there. Any questions? Okay, and then this is just midterm review, like he just said, it's only about 30%, but in previous finals, I mean, I don't want to speculate, but previous finals, memory management's always important because that's pretty much the foundation for everything. And then like I just said, process states, like those are like something that you should always be thinking about because literally every single data structure and every single algorithm that we build on top, like all the message passing, the internet, all this stuff is built on top of process states and doing message passing. Yeah, but he just went over most of this. Okay. And here are the most important functions. I don't know how nerdy you guys are feeling, but for Xenu, obviously all these functions are really available, and I found some of my best practice whenever I was actually studying for this final, because the final can get pretty tough. It's just going through these functions and just reading and understanding what they do line by line. I understand it can probably get pretty boring if you are not particularly fine with Xenu, which I know a fair amount of people that aren't. But all these things are like very important, especially sleep, context switch and reschedule, and read. Like these things, they kind of came up on midterm, I'd say, with some of you guys' questions too. Like understanding what calls what, that's something that is very relevant. Any questions there? Okay, so this is the first thing. Virtual memory, I would totally expect a question about this. Maybe you might have to do math, it might be more of a conceptual question. I couldn't really tell you right now, but just like some of this information, like understanding like how the page table entries, like how the power here actually interacts. Like these are things that are more covered in the textbook, but I just wanted to like kind of help you guys understand that this is all very important information, and that like some of these numbers are just things that you should remember. Like if you want to go into more detail, you can, but just understanding like the sizes for each system that'll pretty much, I would say, be all you need to know for now. Okay. So this is, honestly, this is one of the questions that got me tripped up whenever I was first taking this class. But the Xenu file system is very different than, I don't know if you guys have studied other file systems or not, but it's very different as you just went over. Again, if you have like been kind of playing around with Xenu, you notice that there's nothing like a make directory. Like you can't do that in Xenu, just because the directory I block is one block, and every single thing that you will ever create on Xenu, if you do LS, it's going to be right there. And then it's kind of like they build off of each other. So if you want to get something from the directory block, it takes you first to the index blocks. And I'm sure you guys, this is all recent material, but I just wanted to go over it. And I think this is a really good diagram along with this stuff down here, just kind of helping you to understand that all of these things build on top of each other. And that whenever you can't get to the data, which is what we all really want, without going through the directory to index blocks. And I don't know, just an example question I guess you could think about is asking you guys to kind of trace a path. Say I want to have a file that's 1,000 bytes. What are the steps that Xenu takes to get all of those bytes? And not having to do that in code or anything, but just going through the steps, I can see that as totally being like an SAQ or an LAQ. Any questions about this, guys? Okay. And then this is more about Unix. This is Xenu right here, but this kind of just shows you the complexity of what the local file system looks like. And I would really expect this to be up here, or be on the exam, because I think that's a really big point of emphasis, because in the industry, no one's using, there are some things that use Xenu, but pretty much no one's using Xenu, and if you're in the operating systems world, understanding how Unix deals with file systems is something that's really important and also really useful. So you guys have, I've had a lot of you guys in TSO, and you've dealt with this, but just understanding like how the pointers work at a high level, how they map to each other, is something that I think should be on the exam and just really important in general. Yeah, and if you really want to go into depth and kind of understand how it interacts with Unix, read FileSys, and you don't need to memorize it. And then he kind of went over this too, but I would really like this diagram showing like how device drivers really work, because that was the hardest like concept for me to understand whenever I was taking this class. I remember it's a hard concept to understand like in general, but basically the way it works at a high level is that the only thing that ever talks to your actual application is the upper half, and all the things that the lower half does is it just receives stuff from the device. It says, hey, I've got something here, I've got something here, I've got something here. And then eventually, whenever the upper half sees that and then it services this, then it passes it up to your application, and that's the way it works. It works this way just so that whenever we are actually we'll go into this in a second, but whenever we're using multiple like lower half devices, like sometimes we can switch them out if we have something that might be similar, like if we're actually I'm not gonna read them. But yeah, just understanding all these things, like this diagram, is something that I think will be totally at least an MCQ. And then this is, this is probably my favorite diagram just because it's so explanatory, but this is an illustration of the device switch table, as we say, but it's like, here are your devices, here are your operations, and each device, it has something for every operation. It might not use the operation, or something might go wrong if you use operation, which is what these are, IO null and IO error. You can read that, but IO null just means that we don't use this function, but it's fine. IO error means if you use this function, something's wrong and you need to not use that properly. You need to not use that properly. And then, yeah, here you can kind of see, like, for open, the console, obviously you need to open it, but whenever you're going to the serial, none of the serial can't open anything, just like conceptually. And I think that mental model of knowing, like, hey, logically, what should this device be able to do and not be able to do is a really good way to understand the device switch table. Because if you just go into Xenu and you try to read those files, I don't know about you guys, but that was really hard for me. Yeah, and here's a really good question too that I don't want to say, but it was, I had, whenever I took this class, I had a question very similar to this on my final. And that's what, kind of inspired this whole thing. But yeah, and then he just went over paging and page tables. Another thing that you might need to get kind of nappy with, I don't know if, I don't want to speculate, but I remember whenever I took this class, we actually had to bring calculators in because they had some page table questions. I don't want to speculate, but yeah. It's all just math and understanding formula, and I don't really want to just reread it to you guys because you see it there, but again, the book is a great reference here. I don't know how many of you guys have been reading the book, but actually at the end of every single chapter, there are questions that are they're knowledge checks, but they're very, very good knowledge checks because, it's straight from the author, and a lot of these questions are also very similar to those. So if you really want, if you're gunning, I want to get 100%, I would say that's a very good way to do it. And also I'll go into what I would say my method is just to do well in the class, or do well in the final. Also, here's the clock. Again, I can't say enough about these diagrams, but it's a very good way to understand it. And the sleep cue is, I think, very intuitive. You just go one after the other, and you just keep adding them. So after 6 seconds, or 6 milliseconds, we get A, 12 seconds, we get B unlocked, 27 seconds, we get C unlocked, and then 50 seconds, we get D. And again, that is a question I'm very confident. I'd be very confident on seeing something like that. And then obviously some types of clocks. This is just more knowledge check stuff. Seeing if you're interested, you can do it. And then this is sleep queue invariant, basically just tells you step by step. If you don't know what's going on in the sleep queue, just go through this and you can solve any problem with it. Any questions? Have you guys covered this? Does anyone know what this is? Okay. Then we will. This is also, anyone see this? Okay. All right, so we'll go through the remote file system then, because this is something I know you guys covered. So what's really important about the remote file system is that you understand the difference between it and a local file system. And yeah, that's just the difference. And that I had this generated with Nano Banana. I think it's actually pretty good, but system startup, this will be a question for sure. Again, like I just went through, like understanding the bootstrapping process, like understanding, oh, what's the first program that runs in the system? Boom, easy question, easy points right there. Just going through, and this is the process, by the way. Like this is the way that things run. You go start, you go null user, then null user runs sysinit, it initializes everything in order, and then you go get interrupts enabled, because you can't have interrupts enabled whenever you're doing all this, because things will start interrupting. And then you do networking, and then null user becomes a null process. Again, understanding this, like that's another quick question right there that I could totally see you on there. And again, yeah, this is kind of silly, but I think it actually does a pretty good job, like understanding like the pieces. I don't know why it's like little bananas, but yeah, read start.s, and honestly, like doing this and reading start.s, any system startup problem, any bootstrapping problem, dude, you guys will be chilling. Okay, and no namespaces coverage, right? Okay. Multi-core systems, don't think so, right? Okay. All right, so this is what my personal, I've helped a lot of kids with taking this class, and I took this class, obviously. So this is what I would just say my do's and don'ts. If you want to do well, obviously everyone has different goals and different expectations for what their finals experience should be, what grade they want. But I would just be careful, because the final is every single time it's never been easier than the midterm. So these are just some of my do's and don'ts. The labs, I think, are pretty underrated in how useful they are, because it makes you think about Xenu like as a whole system, not just as like one little piece, if that makes sense. And also, don't just plug everything into Notebook LM, like aside from copyright reasons and everything, like just plugging all the slides into Notebook LM and then plugging this in and any lab information. It kind of doesn't have any focus, is the best way to put it, and it'll just generate you all different types of questions. Trust me, I have experience doing this, so it'll generate you all types of questions, all different degrees of varying difficulties, and it's not as good as just rereading slides, rereading the book, and hey, reviewing this. So, yeah. Yeah, so also don't skip on the midterm review. I know we only said 30%, but sometimes that 30% can show up in mysterious ways, or it can be the underlying foundation. This is something that I experienced in my final, by the way. The underlying foundation for something that you use later, and if you don't understand the foundation, there's 10 points coming, you know? So it's just, yeah. Does anyone have any, like, I don't know, any questions about what they should be expecting on the final, or like anything that they're interested in, like from this? Anything? Okay. Also, come to my PSO on Wednesday at least. I was thinking about, if I have enough interest, maybe like writing down some questions on paper and then releasing them to you guys, and then we can do like kind of a group paper review session. I've always, as I've gone through college here, I've always found that reviewing on paper is just the best way to do it. I don't know if you guys did sports, but you know, practice how you play. It's always helped me the most. Yeah, and here's some example questions. Like, these are all questions that I either don't directly remember, but I kind of get the fuzzy feeling that this is something that would totally be relevant, or stuff I do remember from my exams. Ignore the affinity schedule, it would know. Yeah, like, let's see, what would be, like, could someone answer that, oh yeah.
Who did you take this class with?
I took this class with Professor Comer.
Okay.
Like, could anyone answer that third to last one for me? I know this was definitely, this was on the, something like this was definitely on the midterm. Yeah. Yeah, there you go. So just stuff like that, like it seems simple now, but sometimes it can come up, and in the exam setting, I know we've all been there, and it can, you're stressed out, you're looking at the clock, and suddenly you can't remember what happens whenever you turn off the input mask. We've all been there. And then, here we go, just some further study, like, these are all things that I would say are totally valid for the final, but not exactly 100% gonna be on there. Although I would say that message passing, I didn't really have it on my final, but I noticed that it's I'd say a bigger portion of this class. So yeah, just doing this review is really good. And also the book, everything that I've gone through so far here is pretty much like chapter by chapter, something on the book. So I would not recommend just like being like, oh, I don't know where to start. I really need to do well on this exam. I'm just gonna read the whole book. Not that I think anyone's gonna do that, but I would just like focus on where you're struggling the most. Like device drivers, this is a chapter that I think a lot of people will struggle with, and a chapter that a lot of people should read, because you get to the end, you read those questions, you're like, okay, I kind of start to get this, and then you go into the exam, and some of these device driver questions that otherwise you're confused about could be a cakewalk. Yeah. And I think that's pretty much everything. Let's make sure. Okay. Yeah, that's everything. Anyone got any more questions? We don't really have time for Kahoot, but I will release that. And those are also really good questions. Yeah. No questions? Okay, yeah.
Where will you release the Kahoot?
I'm just gonna put it on the EdStem, and I mean, you guys can play it as flashcards, or honestly, that would be also a good option if I get some interest, like if you guys like the EdStem post, and you wanna come into my Tuesday PSO, so tomorrow at 8:30, I won't be mad if you don't come to that, but just saying, and we can do the Kahoot live. Yeah, what's up?
Do you think you could like solve the memory question, the virtual memory question for the midterm and like post it on discussion? Or like if we could get the answer to that, it would be great.
No, we're not going to post solutions, but go to the session, the TAs can explain the answer to you.
Yeah, if you come to one of my PSOs, I can explain it for you.
Yeah.
What's up?
So go to the PSOs. We'll post all the questions, but we won't post any answers. So we'll also post a few practice exam questions, but still no answers. But go to the PSO sessions, TAs can explain the answers.
Yeah. What's up?
Do we need to bring a calculator to the final?
The calculation that you need to do won't be, it's okay, you can take a calculator, but the calculation you need to do, it won't be that complicated.
Yeah. That's, you have a question?
Yeah, I was gonna ask, I know you mentioned with TSOs, the question, the professor also mentioned that they'll be posting some questions. Well, you are all planning on posting the past midterm, so can you do that as well? Or?
I would imagine not, right? Not posting the midterm?
In addition to the questions that you're posting, will you be posting the past midterm?
Oh, no, we won't post the midterm questions. But go to the PSOs if you want to, Yeah, so if you want to review your midterm exam, this week you can go to my office hour on Wednesday. But the TAs, they don't have the midterm exams anymore, right? So go to my office hour.
What's up?
So do you have like, I know like the professor said like the module with like the shell stuff that we learned last time isn't gonna be on the final. Do you have any like other modules that you know like won't be on the final, or is it just?
I think that I listed in the review, right? So,
I mean, it said like all lecture slides, right?
yeah, but those ones that are highlighted in the midterm, final exam questions, right? Those will be covered. Okay, so I can tell you shell script, user interface, right? Shell is not included. TTY, that console device is not, right? Those are not, those two are definitely not, but the others are possible.
What's up?
Alright, so it's multi-core,
Oh, no, this is a relic part of it from whenever I took the class, and yeah, I kind of just skipped through those things, because I think the scope was just a little different, and yeah, I wouldn't worry about that. Yeah.
So what's your approach to like studying the ZIL files? Like I know you said these
Yeah.
guys on C start, but like some of the stuff like when you have like upper and lower, like upper and lower memory manager, upper and lower and all that, kind of confusing. So
Yeah, so I would say the best way that you could do that is just order your studying of the file system by how much in your mental model you think this file gets used, like this function gets used. Because things like ready, things like context switch, things like create and resume, or open, these are things that I think are much more important that you understand the underlying code for it, because it's just so commonly used. Whereas you go to I don't know, RFS, local file system communication.c, it might be on the final, but you probably only need to know a high level of what that does as part of its bigger bigger algorithm. Whereas something like ready, you need to know it's important that people know how does a function or does a process become ready. Does that make sense? Okay. What's up?
You know if the exam will be 100 minutes or 2 hours?
2 hours.
Yeah. What's up?
how much emphasis do you think will be placed on the resource allocation algorithms?
That's a good question, because it's kind of, I've seen 2 finals so far, not from this class, but I would not think about it a lot. I would say in terms of any resources, the only thing I would think about is kind of focus more on virtual memory if you're worried about sort of the memory and the numbers games. Anything else?
Can I ask how similar was our midterm to your midterm when you were taking?
Ooh, that's a good question.
That's not something that you should answer.
Oh, okay. Yeah. Okay, is that all?
So the point is to tell you guys the scope and how to study, not to tell you guys directly what will be the questions. Okay. Let's look at a couple of practice questions. All right. Okay, so this is a practice from a long time ago. So, yes.
I have a question. Is the mini OS gonna be on there?
Oh, yeah, that's a good question. So, I need to post an announcement, right? So, I think let's focus on Zenu. I don't want you guys to spend extra time to read another repertoire. So focus on Zenu. If there's gonna be coding questions, will be about Zenu. Okay. Yeah, let's skip that mini OS. All right. Yeah, so look at the question for a couple minutes, and then we'll discuss the solution. All right, so let's start from the first two questions. These are relatively straightforward. Okay? So how many blocks does it have? And how is it calculated? Yes.
9 kilobytes divided by the page size, so it'll be 18.
Yeah. Right. 9 divided by 0.5. Right? Okay, 18. That's good. How many I blocks does it have?
32,
2. How is it calculated?
because it uses the first I block has all 16 B blocks occupied, and then you need the second one for the last one.
Right. So you have 16 pointers in each I block. Right? So because you have 18 data blocks, you need 2 I blocks. Okay. All right. So the third one might take a bit more longer. Right? So yeah, read the third question and take a minute, think about the answer. Take a guess. Any answer? Yes.
Is it 20?
I think disk blocks. That's a good guess. So they but remember, I blocks are linked list. Data blocks are not linked list. You do not need to traverse data blocks. I guess probably you are thinking about the need to traverse data blocks. Yeah, you don't need to traverse data blocks. Yeah.
Actually, just had a question. Are disk blocks both index blocks and data blocks? Is that the question?
Okay. Yeah, that's a good, also good clarification question. Disk blocks can store index blocks, it can also store data blocks. Remember, disk blocks are usually, index blocks are usually smaller than one disk block size. Right? Data block is the same size as a disk block. Yes? Three? Yeah, in 3 or 2, right? Depends on when these two index blocks, whether they reside in the same disk block or not.
They're said to be in different physical disk blocks, so it would have to be three.
Yeah, if they're indifferent.
They are stated to be indifferent, so it is three.
Oh, yes, they do.
Suppose the iBlocks of foo.pdf are located in different.
Oh, indifferent, okay, yeah, thanks, thanks for the clarification. Yeah, so if they are indifferent, yeah, there will be 3. Right, so you get the first index block, and you find that the last block is not in the first index block, then you need to get the second index block, and once you get the second index block, you can directly load the last data block inside. Oh, sorry, yeah, first sentence here, I didn't say it. Okay. So the exam questions in the final exam, it can be simpler or more complicated than this, but won't be too much difficult. Okay. So there are some questions that calculation is simpler. There are some questions that calculation is a bit more complicated, but yeah, you can expect questions like this. All right. Yeah, take 2 minutes. Read this question. Okay, it's not too complicated, right? So let's start with the first one. Which page will be selected for eviction if first in first out is used? Page 0. Why?
It was the first loaded into memories.
Right, because it's the first one that was loading.
Doesn't page 2 have a load time of 120, or am I not able to read that?
Oh,
Wait,
right. Yeah, actually, page 2. 1, 2, 2, 6, 120. Yeah. Okay, yes.
sorry, is it based on load time or last time was reference?
That's a good question, right? So I think that's a very good observation. I think the reason that we got confused here is because in the lecture content, we did not mention reference. And we didn't mention reference. And in the version of the first in, first out algorithm that we studied in lecture, load, right? Whoever is first loaded is considered the one that is entered the queue, earliest entered the queue. And that's why page 2 is the one that will be effective using first in, first out. But I think in reality, right, so reference bit will be considered, right? And if reference bit is considered, then the one that's not referenced, you will need to consider the first in, first out among those that are not referenced. Right? That will be page 0. But that is approximating LRU. Right? You use reference bit to approximate LRU already. Okay. All right, but forget about this reference bit. Right? These bits are usually used to approximate LRU algorithm. Now, what about LRU policy? Right? Not approximation, but LRU policy.
Page 0, because it was the least reference.
Right, last reference. Right. Yeah, page 0. This time it should be last reference. Right? Yeah, that's page 0. Okay. All right. So now moving on. Right? So we'll discuss these bits, right? Reference bits, dirty bits. Right? The next question is that page 3 might actually be a better candidate for election. Right? Than page 0. Right? The one selected by RU. What is the reason? Yes.
Because it's not dirty, so you don't have to pay for flushing it.
Yeah, it's a 30 bit is 0. Okay. Okay. So you don't need to write things back. Okay. All right. So we see some pages with reference bit 0, but they were referenced in the past. Guess why that is possible? Right, so these are reference bits. Right, although they are 0, but these pages they were once referenced in the past. Right? Otherwise, how are they loaded into memory? Okay, what would be the reason? Yes.
I just had a quick question about all these policies. Do these, like for LRU, is the only factor just the reference time? Do we not consider dirty bit a reference bit at all with LRU?
We're talking about the ideal LRU.
Okay, so it's just strictly
Right,
like
just
that.
ideal LRU. Right? Because reference bits, these are used to implement an approximated version of LRU.
Okay.
Because ideal LRU is very expensive to implement at lower level.
So for something like the clock replacement policy, that would use dirty bits and reference bits?
Yes. So sorry, let me clarify. So the clock or second chance algorithm, by default they do not have to use the dirty bits, but usually in practice they do consider dirty bits. They prefer to evict the pages that are not dirty. Okay. Right, so the clock algorithm is mainly about second chance. Right? So approximate LRU by giving pages second chance if they were referenced in the last round. Yes.
I feel like a lot of the answers to these questions have had it's like, oh, if we use like this ideal version of this algorithm, then it would be this, or there would be this if we use like this other different thing. So like, do we need to like be clarifying these like assumptions?
You can write down these assumptions, but here I don't think there's anything that's not clear. Right? LRU, first in, first out, these are referred to the ideal version, just by the name. If we did not mention clock, right, clock is an approximation of LRU, right? We didn't mention clock here. We were not asking you second chance algorithm or clock algorithm. We're asking you LRU. Okay. Oh, third question? Okay, again, some pages, their reference bit is 0. But in history, they were referenced before. Yes.
Maybe they were dirty, and then you flushed it out, and then it's reposted it back to 0.
Okay. Yeah. Yeah. Let me see. Okay. So let me just give you the answer, right? So this is we already explained it, right? This is a cost of the second chance algorithm. If you have reviewed, remember second chance algorithm, the clock algorithm, how does it work? It gives you a second chance. If you were referenced, if the page was referenced in the last round, it will have reference bit as 1. So that page will not be evicted, but they will set that reference bit to be 0 and then move on. That's how it gives you the second chance. Right? So page 3 or page 0, the reference bit is 0 because in the previous one their reference bit was 1 and it was reset to 0. Okay, if this round the replacement algorithm scans through them again, right, reaches let's say page 3 again, you'll see that you don't have second chance. Your reference bit is already 0. You do not have second chance, and you are the one that will be replaced. Right. That's a second chance algorithm. All right. So this is a page replacement. So these two, right, file system, virtual memory, page replacement algorithm, these are all what we major concepts we have learned after the midterm. Okay. The exam questions that you will have will be similar to them. So I think that will be all the questions we'll explain, right? They cover the most important concepts we have learned after midterm, memory management and file system, right? So we will post a few more exam questions. They are not too difficult to answer, right? So go through similar to what we did before midterm. Right? Before midterm, we also post exam, some practice questions, but you need to figure out the answer yourself, okay? And so if you have any questions, go to the PSO sessions and my office hours this week, right? Yeah, so one thing, I think currently the DSAI building is still not open to public. So when you visit my office hours, send me an email. Right? So I'll open the door for you. Okay. Yeah, and lastly, right? So if you are interested in research, right? So I do testing and debugging for cloud systems, and we are also building a system that supports AI agents. Right? So it's a pretty interesting topic, and we have built some prototypes. And the idea is to exploit how AI agents use computers differently compared to human. Right? Yeah. So if you're interested in this direction, let me know. And we also have a project that tries to do research training for graduate students. The point is that as senior researchers, a lot of us have already identified that the recent AI is very helpful. Right? It's a lot of times too helpful. Right? So it's replacing a lot of junior researchers and junior positions. So that means that students, or it might be harder, right, for students and junior workers to get their training. And because senior researchers, they can just use these AI tools and they are very, very effective. Given this trend, how do we make sure that the students and the junior researchers still get the training that they need? This is one of the projects we're working on. So yeah, if you're interested in these research directions, send me an email with your transcripts and let's discuss them. Okay, that's it for this course, and there won't be lecture on Wednesday, but make sure, I think the course evaluation might still be open, right? So make sure that to do the course evaluation and let me know. I think as I mentioned last time, because AI assistants these days taking over, what would be the best way to help students to learn in this era with AI? Let me know what you think. All right, that's it. Thank you.